trial 3 of airbag testing in 3, 2, 1.
Woo! I think it's working. How's it doing?
Good.
Why is it deflating? Why does it look like it's deflating? Is it deflating? Nope, still some tension in there.
You gonna cut your voice out of this? Or the whole class is gonna hear you talking about it?
No, the whole class is okay. Look it! It's perfect!
Okay, this is our chemistry airbag lab, and the first thing we're going to do is talk about our hypothesis, which was if the force of the impact ruptures the internal bag, then the chemical reaction between the acetic acid and sodium bicarbonate will produce enough carbon dioxide to fully inflate the gallon bag. And then for our steps taken to solve the problem which was how can your team design a model automobile airbag with the lowest possible mass that expands to the largest possible volume without breaking. So these were the steps we took.
So the steps we took to solve the problem that Lauren just said was we first researched information on actual airbags used in, well, actual vehicles. What we researched was the chemicals used to inflate said airbags, the sensors used to detect a crash and deploy the airbags, how fast these airbags will inflate and then deflate after being fully inflated, and where these airbags are located. We also researched homemade airbags other people had done. We used what they had as inspiration for our experiment. We also looked at possible airbag designs. We discussed these. I think there were 5 we had discussed, and we chose one that seemed most likely to fully inflate and the easiest to create.
Okay, so for our data and calculations, the first thing we did to figure out how much gas we needed to fill the bag was use the ideal gas law, and we ended up finding out that we need 0.1549 moles of carbon dioxide to fill our gallon bag. Then we calculated how much of the sodium bicarbonate and acetic acid we needed. We ended up needing 13.01 grams of sodium bicarbonate and 9.302 grams of acetic acid. You want to talk about the hypothesis?
Not really.
No? Okay, so our hypothesis was accepted. The force of the toy car that we used did rupture the internal bag, and then it fully expanded. The calculated amount of acetic acid and sodium bicarbonate worked, and the bag inflated to its full capacity, and it didn't pop either. It was fully blown.
Well, it didn't pop until I drop kicked it.
Yeah, but
Then it went everywhere.
you didn't need to tell them that.
I didn't need to tell them that. That was a vital part of our freaking
All right,
experiment.
moving on. Possible errors. Jeffrey, you can discuss
All right.
this.
Well, most of the errors are probably because of me. But anyways, possible errors would be incorrect measurements, such as the scale and the cup that we used to measure it.
We used a really old scale.
Like, really old. It wasn't digital. It was actually, you
Yeah.
put it on there, and you have to watch the little needles
Yeah,
slide
so
up and
we
up.
probably did that wrong.
Mm-hmm. And our math could have been off, sig figs and all that. The Barbie car that we used to ram into the bag may or may not have punctured the bag, causing some of the gas to leak, but we don't think that happened because it seemed
Yeah, it was
pretty
really
inflated.
Yeah. Okay, suggestions
No,
for...
I want to do this too.
Okay.
And for suggestions for future experiments, probably use a little bit more advanced scale, at least a digital one that could go into the thousandth place, and a lot better measuring equipment, so we could have gotten accurate representation or accurate figuring out, is that a thing? Yeah, accurate figuring out of how much acetic acid to use.
All right, is that everything?
I think that's everything.
Okay, that's it.
Bye.
Bye.